intern at MXC Technology. I am doing this internship of embedded system. During this internship, we have built a project based on a MPLab XID and PiximLab simulator. We have built a project that is microwave oven simulator. This project is built in a group. There are three members in our group. They are Monisha GR, Maulia SK and myself Priyadarshini CP. The topic we have learned during this internship are C programming, embedded system and microcontroller programming using MPLab XID and PiximLab simulator. So now we are going to discuss about introduction to C programming language, embedded system, microcontroller and what is microwave oven and what are the requirements that are used in a microwave oven and what are the components have been used in this project. Firstly, we are going to discuss about what is C programming language. A C programming language is a general purpose programming language created by Dennis Ritchie at Bell Laboratories in 1972. A C was originally designed for Unix operating system. C is basic for many other programming language including C++, Java and Python. So it is called as mother of all programming language. It is used to write a compiler, operating system, text editors and database system and many more applications are used. So, by understanding C programming language, it can help us to work in computer and design applications in the computer. These are some keywords used in C programming language. Now, the embedded system. The embedded system is a combination of computers, hardware and software designed to perform a specific function or a task. Embedded system may also function within a larger system and this system can be programmable or have a fixed functionalities. They are usually designed to only perform this function repeatedly, but a more developed embedded system can control entire operating system. The general purpose system is used to perform large number of tasks, whereas an embedded system is used to perform a specific task. Thus, this figure shows how embedded system works. Next is microcontroller. The microcontroller is an integrated circuit which is capable of being programmed to perform a specific task. The microcontroller contains circuitry of microprocessor. In addition to that, it has RAM, ROM, I/O ports, timers, counters and serial communication ports. These are built on a chip. It has a multifunctional pins which is help us to perform the tasks. Now, what is micro oven? The kitchen appliance that cooks food by passing an electromagnetic wave through it. There are several modes in the various micro ovens, but in this project we are going to implement only 4 modes. They are micro mode, grill mode, convection mode and start mode. The first mode is micro mode. The micro mode is used to cook the food in a traditional manner. It uses the power of 900 watts. In this mode, the maximum time that you set for cooking is 60 minutes. On pressing a key 1 in a matrix keypad, the micro mode is selected. The CLCD displays the power. The CLCD prompts the user to enter the cooking time. The start button clears the time and the hash button confirms the time and starts cooking. The next mode is grill mode. This mode is used to cook meat and bread. It works as micro mode, but the purpose is to cook meat and bread. The user can set the time as per cooking time of meat. On pressing a key 2 in a matrix keypad, the grill mode is selected. The CLCD prompts the user to enter the cooking time. The hash mode confirms the time and starts cooking, and the start button clears the time. The next mode is convection mode. The convection mode user can set oven to preheat for a particular temperature. On pressing a key 3 in a matrix keypad, convection mode is selected. CLCD prompts the user to enter the cooking temperature. Start button clears the temperature and the hash button confirms the temperature. Oven starts preheating with the given temperature for 3 minutes. This is how convection mode works. The last mode is start mode. On pressing a key 4 on in a matrix keypad, start mode is selected and cooking time is set to 30 seconds and cooking starts automatically.
Amalia, I'm continuing with the requirements part where here we use MPLAB XIDE and XCIDE compiler, PixMLab. In PixMLab, we use a PIC Genius board and PIC 16F877A microcontroller. Next, PixMLab architecture, which it can operate up to 20 MHz frequency. Operating voltage is between 4.2 volts to 5.5 volts. Does not have an internal oscillator, which it maximum current each port can sync or source is around 100 microampere and contains a 40 pins and 8-bit controller. As coming to the LED, where in microwave with an embedded system, the LED function as a visual display element, typically used to show the time, power level or operational status of appliance, controlled by the embedded microcontroller within the microwave, allowing for precise elimination of the digital digits on the control panel. Where LEDs are commonly used in 7-segment display format to show numbers on the microwave control panel, allowing user to easily read the cooking time or other settings. In embedded system microcontroller within the microwave directly manages the LEDs by sending signals to activate specific segments of the display to perform for the desired digits. And the next is matrix keypad interference, where matrix keypad interference is a small compact input device which accepts users input and processed by the microcontroller. In this project we used to select cooking modes, set the timers, etc. This is a keypad in which numbers of tactile switches are connected in a row and column concept, where RB act as the inputs and RD0 and RD3 act as output. 4 into 5 matrix keypad has the total of 12 push buttons. Where in a microwave refers to the technology used in microwave's control panel, where as I said, a grid of button is arranged in rows and columns, which allows the user to give the inputs by pressing a single button at the intersection of specific row and column, with the microwave's internal circuitry detecting which button was pressed based on the matrix layout. Essentially, it's a way to read multiple buttons input using only a few connection wires, making it a compact and efficient design for appliance and control panels. As in the working part, when the button is pressed, it completes a circuit between a specific row and column, allowing the microcontroller within the microwave to identify which button was pressed based on the activated combination. The next part is switches, where tactile switch is a switch whose operation is perceptible by touch, and this switch is used to select the mode of operation and to enter the temperature and to enter the time in our project. The switch will produce a bouncing bullet when a switch is pressed. A microwave can have multiple switches as including RF switch, a door interlock switch and monitor switch. These switches help to prevent microwave energy from escaping from the door is open and to route signals to the microwave. And the next, the bouncing effect, where in a microwave the bouncing effect refers to how microwaves, which are electromagnetic waves, are continuously bounce off the metal interior walls of the oven cavity, creating a pattern of standing waves until they are absorbed by the food inside, effectively eating it even throughout the cooking chamber. Next, timers. Where a timer is a specialized time of clock which is used to measure time intervals. It maintains the timing of operation in sync with the system clock or an external clock, where timers used to count cycles and perform a particular action at a specified movement or optional start and interrupt cycle. In this, we basically has a three timer modules where microwave timers allow you to set a specific amount of time or cooking for other tasks. We can use the timer to set food before cooking and run the timer for tasks other than cooking such as resting food. Next, CLCDs, buzzers, and fans. Where CLCD is refers to a character LCD display, which is a small liquid crystal display used to show text information like cooking time, power level, and other settings on the oven's control panel, allowing users to interact with the microwave through the embedded system by displaying these details on the screen. Where the function of CLCD is provides a user interface to input and view cooking parameters like time, power level, and sometimes even specific cooking modes. Interfacing with microcontroller, where CLCDs is connected to embedded systems microcontroller through dedicated data pins, allowing the system to send commands to update the display with relevant information. Most microwave CLCD display basic text characters including numbers and letters to show the selected settings clearly. Where in the working part we can see that embedded system microcontroller sends a data to the CLCD through specific register addresses, controlling the what characters are displayed on the screen, and data transmission, where the LCD module receives data in a specific format including commands to set the cursor position, character data to display, and the other control signal. As we come to a buzzer is in a microwave often refers to a small electronic component that produces the beeping sound when the cooking cycle is finished, altering you that your food is ready to be removed. And all over the range, microwaves have automatic fan feature to help protect the electronic components as well as help the cooking area to get rid of the excess heat. The built-in the remote automatically turns the vent fan on if the appliance is too hot and will not turn off until the microwave is cool again. And we also learned coding on all these concepts. And thank you. Next part of simulation will be explained by the another group member. It's Monisha. Thank you.
Here this is the CLCD. It displays four different modes, that is micro mode, grill mode, convection mode and start mode. In micro mode is used to cook food in a traditional manner. It uses maximum power of 900 watts, and in this mode the maximum time that you set for cooking is 60 minutes. On pressing key 1 in the matrix keypad, micro mode is selected. The CLCD displays the power, and here we can set the time. I am going to set 3 seconds. Then I have to enter here. After entering this, fan starts to run. Observe this, and after ending of time the buzzer will turn on and it will make some sound. Now I am going to enter it. This is all about micro mode. Next one is grill mode. I am going to select grill mode by selecting 2 in matrix keypad. This grill mode is used to cook meat and bread. It works as the micro mode, but the purpose is to cook meat and bread. Here user can set time as per the cooking time of bread or meat. And on pressing key 2 in the matrix keypad, grill mode is selected. CLCD prompts the user to enter the cooking time, and I'm going to enter 18 seconds. Now I have to enter. If I want to pass, then I have to press key 5 in matrix keypad. Here it is pause. And if I want to stop, I have to choose in 6. This will stop the mode. And if I want to start again, I have to press 4. This will resume the mode. We can see a fan is running, and after ending the buzzer will make sound. Now I am going to select convection mode. In convection mode, user can set the oven to preheat for a particular temperature. On pressing key 3 in the matrix keypad, convection mode is selected. Yeah, I have already selected that. And CLCD prompts the user to enter the cooking temperature. Here it's showing set temperature, and this is for clear and this is for enter. Now I am going to select some 45-degree temperature. I have to enter. Yeah, its oven start to preheat for a particular temperature and it starts for 180 seconds, and we can observe fan is running, and this buzzer will make sound after time up. And this is matrix keypad. This is set of LEDs, and we can set these LEDs by these switches. This is port P, port T, RB0, RC4, and many more. And these two are relays. This is EEPROM, and this is the reset pin. If I want to end this, I have to click reset. And this is the following which prompts the user to enter cooking mode.